Hi class, how are you today? That's scientific. The learning target for today is to be able to convert numbers into scientific notation and perform arithmetic operations on expressions written in scientific notation. So arithmetic operations would be adding, subtracting, multiplying, and dividing. For the scale, for a 3, you can add, subtract, and multiply, divide expressions written in scientific notation. So you can do all 4. You're a 2 if you can add and subtract or multiply and divide expressions written in scientific notation, one or the other, but not both. You're a 1 if you can convert numbers into scientific notation. And you're a 0 if you cannot convert numbers into scientific notation. All right, let's get started. All right, so in science and lots of things, we deal with very large numbers. And instead of writing those very large numbers out, we have something called scientific notation. Scientific notation makes it a lot easier to say really big numbers without saying the really, really large number that it is all the way out. It's kind of a shorthand to say really big numbers. So one example is we have the speed of light. The speed of light is 186 miles per second. And between the sun and the earth is 8 light minutes. So it takes 8 minutes from the light of the sun to get to the earth. And so to get that really big number, we say, okay, it's 186,000 miles per second, and there are 8 minutes. So we know that there are 60 seconds in a minute. So we have 8 times 60 is 480 seconds. And if the speed of light is 186,000 miles per second, then it's going to be 186,000 times 480, which is 89,280,000 miles. That's a pretty big number. And instead of saying 89,280,000, we can shorten that using scientific notation. And the sun is not the farthest thing from us. We've got planets that are much farther. We've got constellations that are much farther, many other stars, anything. So we need to say these really, really, really large numbers, but not say their entire number. So instead, we use a shorthand called scientific notation. Okay, so first of all, with scientific notation, it's going to be a number times 10 to an exponent. And that number we're going to call a. And a is somewhere between 1 and 10. And so in this case, on the left, we have 3.25 times 10 to the 6th. So 3.25 is between 1 and 10. And we're multiplying it by 10 to the 6th. What that means is we take the 3.25 and we move the decimal point 6 times to the left. So 1, 2, 3, 4, 5, 6. And so we have zeros in all of these slots. So 3.25 times 10 to the 6th is the same thing as saying 3,250,000. On the other one, very similar, 3.25 times 10 to the negative 6. You take the 3.25, but this time, since it's negative, you bring the decimal point to the left. So 1, 2, 3, 4, 5, 6. And so we have the decimal point here. 1, 2, 3, 4, 5, and the 3 makes 6. So this is going to be 0.00000325. This works for really, really small numbers. And yes, just like we can get really, really big numbers, we can also get really, really small numbers. If you're talking about looking at microorganisms or any atoms, anything that are really, really small. All right, now we go back to our speed of light example. 186,000 miles per second. So 186,000 doesn't have a decimal point that you usually see. So it just ends up at the end of the number. So we have the green arrow pointing at where the decimal point would be, at the end of the number. And so to convert that into scientific notation, we need a number that is between 1 and 10. So we want to move this decimal point, and we move it 1, 2, 3, 4, 5. So we've got 1.86. So it's between 1 and 10. It's 1.86 times 10. And we moved it 5 times, so it's 10 to the 5th. So 1.86 times 10 to the 5th will give us 186,000. Now let's do the same thing with that number we got before. So the distance between the sun and the earth, 89,280,000. Again, we've got the decimal point at the end, and we say 1, 2, 3, 4, 5, 6, 7. So 8.928 times 10 to the 7th. So when you're dealing with big numbers, the big number, you're going to have the decimal point at the end. Remember, even if you don't see the decimal point, it's going to be there. It's just at the end of the number. You'll have to add it in. And we do the same thing. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so that gives us 4.8 times 10 to the 10th, because we counted 10. For small numbers, we do the same thing. We take the decimal point and we want to move it to make the number between 1 and 10. So in this case, we want to move it after the 1. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So we moved it 9 spaces. So we're going to have 1.23 times 10 to the negative 9. So small numbers get negative exponents, big numbers get positive exponents. All right, now that we've learned how to convert into scientific notation, we're going to learn how to add, subtract, multiply, and divide numbers in scientific notation. So for adding, it's just like if this were, say, 6x cubed plus 7x cubed. Same thing. We just add the coefficients and leave the bases alone. So we're going to have 13x cubed. That's what we would normally get. And just like when you're dealing with polynomials, you have to do the same thing here. They must be the same base and the same exponent. So we've got to have the same base, which in this case is 10, and the same exponent, which in this case is 3. It's got to be the same, or you cannot add them this way. So we do the same thing. We add 6 and 7, and we get 13 times 10 to the 3rd. The base and the exponent do not change with addition. However, we've got a problem. Now, 13 is not between 1 and 10, so we need to make it between 1 and 10. So we need to take that decimal point and we move it over 1. So since we're making the number smaller, that means it's a bigger number, so we add to the 3. So we now have 1.3 times 10 to the 4th. So we added 1 because we moved that decimal point over. Subtracting works exactly the same way. You need the same base and the same exponent. We've got 10 for the base and 4 for the exponent. And so we subtract the coefficients. So 9 minus 5 is 4 times 10 to the 4th. Again, the base and the exponents do not change. So we've got 4 times 10 to the 4th. Quick check, is 4 between 1 and 10? Yes. So we're done. That's all we have to do for this one. Multiplying is the same thing as multiplying when you're dealing with x. So in that case, the general form is always x to the m times x to the n equals x to the m plus n. And you multiply the coefficients in front. So the example, 3x to the 5th times 6x to the 4th. 3 times 6 is 18, and 5 plus 4 is 9. Exactly the same way here. We multiply the coefficients. 8 times 9 is 72. And 10 to the 4th times 10 to the 7th, it's going to be times 10 to the 7 plus 4 is 11. So again, you add the exponents. But is 72 between 1 and 10? No. So again, we need to take the decimal point and we move it 1 to the left. So that's going to give us 7.2 times 10 to the 12th. And now dividing numbers in scientific notation. So same thing with dividing. If you had x to the m over x to the n equals x to the m minus n, you subtract the exponents, and the coefficients you just divide like normal. So 18 divided by 3 is 6, and x to the 12th over x to the 8th, 12 minus 8 is 4. So you get 6x to the 4th. Same thing in scientific notation. Except when we're dealing with exponents, I usually want you to reduce the fraction. In this case, I want you to give me the decimal. So in this case, we're going to get 4 divided by 8 is 0.5. And then 10 to the 7th over 10 squared, 7 minus 2 is 5. So times 10 to the 5th. Now we need to check, is 0.5 between 1 and 10? No. So we need to move the decimal point 1 to the right. So this is going to be 5 times 10. And since we made it a bigger number, that means we need to subtract 1 from the exponent. So this will be 5 times 10 to the 4th. For number 1, I want you to write those numbers in scientific notation. So for A, you've got a big number, change it into scientific notation. For B, you've got a small number, change it into scientific notation. For number 2, I want you to simplify, but keep it in scientific notation. So A, we're multiplying, and B, we're dividing. All right, that's it for this lesson. Once again, please make sure to take notes on the entire lesson. Take a picture of everything, including the sponge activity. Submit it all to Google Classroom, and have a good night.